I'm sorry to interrupt again, but I am not a math whiz, so I always need your expertise.
Whose paper is it? Blake's? Oh boy.
Will you accept that there's no line on this side?
Yeah, that's fine.
Oh, this side, okay. Thank you.
Goss, what you got?
Here's the answer, print 7.
Number 7's answer was a squared b cubed plus ab squared. Harper, go.
How do you do 1?
Find the greatest common factor of this. People get greatest common factor and these common multiple mixed up. Greatest common factor is what, remember the key word is factors. What is the biggest factor? What can you take out of them? It'd be a little like if you're reducing fractions. You know, if you have 12 over 18, what's the greatest common factor? What can you reduce them by? 6. Well, you're looking at that same thing for this. If you have 6 and 9, what's the biggest number you can take out, divide them by? Arthur, 6 and 9, what number goes into them? 3. Well, then you look at each letter. This has an x squared, this has an x. What's the biggest you can take out of both of them?
X.
Just an x, because I can't take an x squared out of an x. So x. So really you think of which group has the least amount of each thing. This has y cubed and this has y squared. So the biggest you can take out of them is a y squared, because you can't take a y cubed out of that. And since they both don't have a z, you can't take a z out of them. So this is the most, this is your greatest common factor. Not again to be mixed up with least common multiple. Least common factor. Well, I thought that was helpful. And in case you're wondering why we're having a test on a Wednesday.
Wait, what? Why are we having
You
a
won't
test
be
on
here
Wednesday?
Friday.
And sex on Thursday.
And Wednesday. You guys are going to be so sex edited up.
Oh my
Yeah.
Wow.
Carter Westfall.
How do you do number 6?
El número, el quinto.
Yeah.
What is that? Alright, Westfall, the only issue with this is this. We don't deal with negative exponents. How do I make something that has a negative exponent positive exponents?
Put it over. Wait, no,
Well,
that.
you move it wherever it's on in the fraction, you just move it to the opposite side. So this is on the bottom, I just pull it up to the top, and when I pull it up to the top, it just becomes a positive exponent. The number doesn't change to positive or negative, and that's all it is. Now there's nothing left on the bottom, so that is it. Y cubed is the answer, I'm guessing, right? Yeah, that's what it says, simplify. I mean, there's nothing more. Had the y, Carter Westfall had the y to the negative third bit on the top, then you would have brought it to the bottom and left the 1 up there.
Okay.
Alton Boyne.
You get 8.
If I were doing 8, the first thing I would do is this, is I would make them all fractions. So this would be 37 over 1. This would be 9x over 1. And this already is a fraction, so I'd leave it 1 over 37. Then I would cross cancel. What can cross cancel, Kurt? Both the same thing. So this becomes a 1, this becomes a 1. There's nothing left but 9x on top. And a bunch of 1s on the bottom, but we don't have to write the 1s because it's just 9x. So, how many people multiply 37 times 9x and then divide it by 37? Does anybody? Yeah, why would you do that?
Well,
I
I did
did
that.
that.
I did that the first
I know
time.
you're going to get it right, but it certainly just makes it a whole lot more goofy. Savage.
We did number 7.
We are just killing it. What's the direction say? Oh, directions just say simplify, right? The only way you can simplify this is if you have like terms. And remember, like terms have to have the same letters to the same exponents. So you're quickly writing on what you're writing. I didn't even see it.
I'm writing the question, so.
Oh, you're writing this down. Oh. So, Abram, in order for this to be put with anything else, it has to have an a squared b cubed. This doesn't have an a squared. This one doesn't have a b cubed or an a squared. This has an a squared b cubed. They can be in any order because in multiplication you can flip orders. So the question, Abram, is this. If you have 3 a squared b cubes and you take 2 a squared b cubes away from it, what are you left with?
A squared B cubed.
Yeah, 1 a squared b cubed. You don't have to put that in. So that gets rid of these. Now you look at these. Are these like terms? Do they both have an a and a b squared? Yes, they do. So if you have 3 ab squareds and you take 2 a squared, ab squareds away, you're left with just 1 ab squared. Notice the exponents don't change. You're not multiplying, so this doesn't become a to the 4th, b to the 6th, or a squared b to the 4th. You're just adding and subtracting. The exponents don't change on that. Tyler O'Connor.
What is number 12 asking for?
Number 12. I don't know if I'll count number 12 or not, but let's just go because we skipped that. Yeah. 12 says this. Determine the values for which the rational expression, which means a fraction, is undefined. They are simply asking, this whole undefined thing is when will the denominator be 0? Because that can't happen. You can never get a 0 on the bottom of the fraction for 10 or rule number 1 over there. So you need to know when is a plus 5 going to be 0. If that happens, you can't do this. So you solve this for a or whatever it is, but this is just common sense. Negative 5 plus 5 is 0. So, and they would write it like this: a cannot equal negative 5. That is. Really should turn the volume down. Turn it off. I mean, that should be an easy one on the old thing. Faith.
17.
Number 17. 17. Oh, I love this one. Now, this one could cause trouble. So, Faith, first thing you do is
Subtracted 2 minus 0.
well, it's distributive property is what it is first. Before you think of it, it is subtracting, but in order to do this, you have to get rid of the parentheses, and then you have to distribute out this negative sign. So the 3z stays, and then a negative times a 2 is a negative 2, and a negative times a negative z actually makes it a positive z. Minus 5 equals 9. Are you with me on that?
Yeah.
Then you'd have to combine, if you're part of Westfall, like terms, or combine them. 3z plus a z is 4z. Negative 2 into negative 5 is a negative 7. And then work it kind of from there. Add 7, so 4z equals 16. Z plus 1 equals 4.
You just did the distributive property with just a negative sign, right?
Right. Well, really what you think about this is it's actually a negative 1.
Alright.
So negative 1 times, it just changes the sign of everything inside there. But this is multiplication, a negative times both of those. Yes, Abram.
18.
I am 16. 16. Now, would this be more helpful or make more sense if you just kind of flip-flop the stuff and put the negative 6a on this side and the 3 over there? I don't know if that make it doesn't matter. But sometimes people would get mixed up because the negatives are like whatever. How do you solve this, Abram? You are going to add the 1 to get it to the other side. So now negative 6a equals 4. And then solve it from there, Carter Westfall?
Divide.
5.
4 divided by 6.
Well, you're negative 6. This is a negative, and divide by negative, so it becomes positive. And it doesn't matter where the negative sign falls, it could be on the top, on the bottom, or outside. One negative makes the whole thing negative, so A equals A negative, whatever that fraction reduced is, 2/3. This actually, to me, should not be that difficult of a test, actually. Especially for a class that's going to get the. Unfortunately, I believe that all those snow days, if we miss by 1/10 of a point or more, I'm blaming the snow days because we've lost valuable learning days.
It's true.
Now, if you all wanted to get together and talk to Ms. Lopez and ask her if she might want to add a couple days somewhere along the line just to get you.
I'll do it.
We'll be.
I'll talk to her. I'm fine with that.
Tyler!
Can you just do number 10? Because I got lost in the number somewhere.
Maybe Gibson sang a song, I think, on that point one time. I think it was I Got Lost in Your Eyes.
You got lost in your eyes, sir. Can you please?
Oh. Concert tickets sell for $12.50 each on Friday night. 375 tickets are sold. If 20% of the money earned from the ticket sales is donated to charity, how much donate? Where did you get lost?
I don't know.
Oh, so the deal is
That's why I'm lost.
20% of the money earned goes there. And percents are always multiplications. So you have to first of all figure out how much money was earned, which is total money. And I assume that just means you're going to have to multiply 1275. I think it's times 375.
Yeah, I did that. I got 4,697.5.
And I'm going to make it 12.5 if that's okay. It's all the same thing. 25, 2, 35, 37, 3, 15, 18.
Wow.
0, what's that, 750? Double 0 is 375. And hopefully you end up with, I was going to say there might have been a faster way to do this, but that's what it would be. 14, 15, 16. Is that $4,687.50? Is that what you get?
Nah, I got one number off.
Wait, did I get that? I think I got it wrong. I did it fast.
No, I think I got it right.
It's alright.
So then you just need this 20% of, which is 0.2, so 4. Or, by the way, do you realize that finding 20% of something is actually the same as dividing by 5?
Yes.
Because it's 1/5. 20% is 1/5, so you can either multiply by 0.2 or divide by 5. Which one would you rather? Oh, look, I think I like multiplication too. 4, 6, 8, 7.5 times 0.2. 0, 1, 14, 15, 1, 16, 17, 12, 13, 9, 937, 50. And just for fun, let's do the 4687.5 divided by 5. 9, 45, 18, what's that? 3, 15, 47, 7, 50. I don't know if that worked out, I just kind of pretended that it worked. But it should. That's just like this. Do you know that finding 18% of 50 is the same thing as 50% of 18?
Wow. Good multiplication.
18% of 50 is the same thing as 50% of 18. So if you're doing 24% of 25, you should be able to do it in your head. 24% of 25 is the same thing as 25% of 24. Which is 4, right?
Which I can't do.
I'm just saying, well, it's easier. 25% is an easy percentage. It's 1/4. Just like this. This is 9 because half of 18 is 9. Well, if you look at it this way, you're thinking, why not get multiple? Does that make sense? Amelia, did that make sense in the end?
Yes.
Harder.
9.
We already did 9.
I thought we did.
Just kidding.
I've got
A hiker walks at a constant speed as shown in the table below. What is the rate of change? Rate of change. You should know rate of change. Rate of change is actually the same as slope. That's rate of change. And what is our little slope formula? It is the change in what over the change in what? What goes on top, x or y? Change of y. It's how high something is. Change in y over the change in x. And change just means subtracting. This is x, and this is y. Wait, who asked this question? Parker. So what you're going to do, Parker, is this. You look at what is the change to go from 6 to 12. You're going to make a fraction with the y, the change, we call it delta. Delta y over delta x.
Oh, that's what I.
What is the change in, to go from 6 to 12, what was the change?
6.
6. To go from 2 to 4, what was the change?
6. Sorry.
Subtract. Give it a round.
Yep.
What's that?
2.
2. So your rate of speed or your change or your slope is 3 whatever miles per hour. Hope that's what that is. Did you write delta x and delta y?
Yeah, I did.
Wow.
Well, actually, I did delta distance over delta time.
Same. Or delta delta delta. Can I help you? Alton Point?
17.
We did that one
We
already.
already did that one.
That one I was right on when I said this.
Oh,
I'll show it to you again. Were you absent? You can always go back and watch it on the video that I will post shortly.
no, 16, not 17.
I love watching these John's videos.
I know you do.
It's Carter's favorite YouTube channel.
It is.
Alright, the deal with 16 is that it has 2 letters that you gotta either put on one side or the other. Altenberg, did you do this? Did you try it?
Yes.
What did you do? Can I ask?
I moved the 2n over to the negative.
And how did you do that?
Subtracted 2n and subtracted 2n.
And if you take 3n and subtract 2n, you get
5.
negative 5n. It's not positive because you're not multiplying.
Yeah, I just put 5.
Oh, no n's at all?
No, I just put 5 in.
So then you're going to divide by negative 5, divide by negative 5, so n is going to be negative 1. Did you not get that either, Parker? You seem to be diligently scribbling that all down.
I think I got it. Yeah, I did. No, I got it.
If you didn't like to deal with the negatives, you could have added 3n to this and added 3n to that, and you get 5n. But then you get plus 5 equals nothing. So then you have to subtract the 5 to the other side. Negative 5 and 5n divided by 5, you're still getting negative 1. It don't matter, but little known things in math. Just like if you were to add, if I told you to give me the sum of 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, what is that? You should know it.
It's a number.
Some of what?
50.
All the normal numbers.
How about 55? Does that make sense?
There's a lot of normal.
How can you do that in your head very quickly? Look. 9, 8, 7, 6, 5. This is another one Gus is going to go, oh.
Put all the things of 10 together.
It's just the same thing you did in 7th grade. 10, 20, 30, 45. Oh, I guess that was wrong. 45. Not 55. 45.
We got it, ladies and gentlemen.
Will be the last.
Yeah.
There's actually a formula for that. All right, Westfall.
What is the answer to 11?
2.5.
How do you do it?
You were thinking maybe by chance you got it right before I.
Yeah.
Number 11. Well, what do you know if they're similar? Westfall, what do you know? They're proportional. If I were doing this, this is what I would do. I would draw myself a ratio box. And I would label said ratio box. I would make, it doesn't matter, I would make this the small triangle, make this the big triangle, and then I would say maybe this is the long side. Oh wait, no, it isn't the long side. It's the long leg. Okay. And I would make this the small leg. What's my other one? The hypotenuse I don't care about because that doesn't ask me that, does it? No. So then fill in the blanks, Carter Westfall. What is the long side on the small triangle?
4.
4. What is the long side on the big triangle?
5 feet.
5 feet. What is the small side on the small triangle? And what is the small side on the big triangle? So there is your equal fractions, whatever, and you're just probably going to have to make equal fractions out of it. 4 over 2 equals 5 over what number? And then how would you do that? Carter Westphal?
5 times 2.
Right, cross products. 4 times x equals 5 times 2. Divide by 4, divide by 4, you get 2.5. 2.5. Is that right?
Yeah. Oh, Carter, 2.5 back.
Another way you probably could have looked at it that would have worked was you could have said this, because the sides, the ratio, the proportion of this to this, how do you go from 4 to 2?
Multiply and divide by 2.
Divide by 2. So if you divide this by 2, you're going to get the same thing.
But I was saying that how do you go to 2 to 4, so I said multiply and change them.
Fake.
It's not a question about any of these, but like in general.
Oh, and an in general question, yes.
Yeah. So if you had like a -2 over 3, would it be -2/3?
Yes.
But
Yeah.
what if you had a 2
Over
a
-3, it's the same thing. -2 over 3 is the same thing as a 2 over a -3, which is the same thing as a -2/3.
Okay.
They all mean exactly
That was
the
my
same. No, I understand. It gets a little complicated. Generally speaking, we write it like this. This is kind of the accepted form. It's pretty rare that you put the negative at the bottom, but it doesn't matter. Sometimes you put it over the top. It's all water under the proverbial holes of them. AG?
How do you get 19?
Oh. Is that over here somewhere? Alright, tell me you, yeah? How do you get the letter Y by itself? First step is to? Did you?
Yeah.
Alright, so let's work on that. Now you have to be careful with this. It is 2/9 minus 5/6. Order is important on this. You have to have them in this order because the fraction, you can't flip them around. Your common denominator is 18. Yes?
Yeah.
This would be 4/18 times 2 times 2. This is 15/18. Okay, now here's what one must kind of glean in all this sort of thing. If you are subtracting this, think about this negative sign as going with the top number. You know, 18 is your bottom number. On top, you have a -15 and a +4. What does that give you? Gives you a -11. Okay? And then, don't forget where you started. I have now a negative y equals a -11/18. You need this, y always has to be, your letter has to be positive, and the simple fix is when you have that, you can just change both to their opposites. It's like multiplying and dividing by -1. So the answer should have been 11/18. Positive 11/18. Eastgate,
They need 20s.
how do I do it?
Yes.
Well, they basically gave you the answer to that, I thought. At a bakery, bagels are $2 and muffins are $3. Let X be the number of bagels and Y be the number of muffins sold. The equation, they gave you all this, Carter. Shows that the bakery made $150 selling bagels and muffins. Find the intercepts. Does that give you trouble how to find the intercepts? Because remember, intercepts were covering up this. If you have zero for x, this goes away. And what does 0 mean? It means you have no bagels. You put 0 in for x, that means there are none of those. And if you had none of those, you would get 50. 3y equals that, so y, the y-intercept is at 50. X is nothing. There are no bagels. You have 50 muffins. Flip that around. If you have no muffins, if y is 0, that's the x-intercept, then you have to have 75 bagels. So you probably should write all that info down, but that's what the x and y-intercept are. All the rest of that makes sense. You kind of chuckle
Yes.
about that. I don't know where the, See, if you looked at the line of that, what did we say the x-intercept was what?
A number.
10, 20, 30, 40, 50, 60, 70, 80. X was there and y was 50. 10, 20, 30, 40, 50. This line represents all the different combinations of muffins and bagels that will give you 75. If you sold, what was this, 10? If you sold 10, what was that, muffins or bagels?
Bagels.
Yeah, if you sent 10 bagels, then you get whatever X amount of, however high this line goes, amount of muffins. Anyways, enough of that. More. You're so close. Evelyn, you think you got a firm grasp of reality? Most of this.
Yeah. For this at least, not like the newer stuff, but this.
Yeah, how'd that point slope work for you? Did you watch the videos?
I
Did
did,
you
and
do
I
that
actually
yourself?
I took the notes.
And you were right, Amelia. I saw the note there. I don't know why that worksheet was wrong for those last 4 problems where it said to use the first point and they used the second point. Good worksheets are hard to find these days. What are you going to do?
Paddling over a rubber band very flat.
Usually the teacher says that you stop doing inappropriate behavior before you get your sentence. That's usually the gist of that. Parker, is there another question in there? Or no? Is your
Can you
name
give another example of 14?
of who?
14.
14.
It was the teacher one.
I put my dad likes burgers, but he's not a chef.
A burger
I bring
teacher.
your preacher.
I like burger.
Oh yeah, I said burger teacher.
It's,
And your notes.
Parker, a little bit like this.
Kids. My dad likes burgers, but he's not a burger.
Where is 14?
It's at the bottom of the last line.
Did I miss it?
Yeah.
Did I cut it off on my thing?
No, you said it.
No, but it's not here.
What?
Isn't
It's as far as it goes. It's the
Yeah,
end
you
of the
must have
road.
cut it off.
It'd be a little like this, Parker. All the kids in Mr. Hahn's classroom are 8th graders, so no.
But that doesn't mean they're all mature.
That's exactly
But
it.
that doesn't mean we're all.
All
got
right,
this
wait,
down.
read me the example from the
Doesn't
text. I
mean
don't know.
we're all
What's it say?
eighth
All what or what?
If a teacher likes math, then she is a math teacher.
Okay, if a student is in this classroom, then they're an 8th grader. A counterexample would be you could have a 6th grader in my classroom. I mean, it has to be true for everything, and that would be not the, yeah, sure, obviously math teachers probably like math, but other teachers could like math. If you can, if you can think of something that proves it wrong, you just have to come up with one example of it. Are all squares rectangles? No, if something is a square, then, wait, if something is a rectangle, then it's a square.
No.
No, because you can draw rectangles that aren't squares. Now the other way around, if it's a square, or all squares are rectangles, then that's kind of a logic there,
I want to make sure my answer is okay. I said my father likes burgers, but it doesn't mean he's a chef.
No, you'd have to give the, did you give the, what's the statement? All chefs like hamburgers, or what was it?
All chefs like cooking.
Yeah. I don't know why you want to be a chef and not like cooking, but that's certainly
Good.
What does
You're a
hamburgers,
boss.
what does hamburgers have to do with your statement?
Because
It's just a counterexample. Well, it said if
Donut.
the